Baik, silakan teman-teman, anak-anak kami semuanya untuk meng-on-kan kameranya, mengaktifkan kameranya, biar kita mulai. Silakan kameranya diaktifkan. Baik, kita mulai ya. Bu buka. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi semuanya. Salam sehat.
Pagi, Bu.
Selamat pagi, Bu.
Baik, ya. Pagi ini kita akan lanjutkan perkuliahan kita di mata kuliah Teknologi Bahan dan Korosi yang nanti akan dilanjutkan diisi oleh Ibu Profesor Insinyur Dr. Mariati Jafar dari Universiti Sains Malaysia. Jadi adik-adik diharapkan untuk memperhatikan, fokus, menyimak apa-apa yang akan disampaikan oleh Prof. Mariati ya untuk lebih memahami apa yang disampaikan. Untuk pagi ini topik kita akan dilanjutkan untuk subjek komposit ya. Baik, Prof. Mariati tanpa memperlama waktu, kita lanjutkan saja, Prof. Dipersilakan, Prof.
Okey, terima kasih Prof Halimah. Okey, apa khabar anak-anak semua? Sihat ya?
Sehat, Bu.
Alhamdulillah sehat, Bu.
Okey, ya. Okey, alhamdulillah. Jadi kita akan lanjutkan syarahan kita, syarahan saya pada pagi ini. Saya share dahulu skrin saya. Sekejap ya. Ini tak ada. Sekejap. Sekejap. Okey, sudah nampak. Okey, nampak ya saya punya slide? Saya
Sudah, Prof.
kenapa? Okey, di sini. Okey. Jadi today I would like to continue our discussion, okay, based on the topic that we discussed yesterday. So I'm going to go straight to the polymer composite. Hopefully, yesterday you already have some idea about what is different types of materials. Okay, we have metal. Okay, maybe very brief. I'll go into this materials tree where we have metal, ceramic, polymer, and composite is a combination. Okay, combination of metal or ceramic or metal with polymer, or it can be difference combination. Okay, it's up to us where we want to combine these materials to produce the composite materials. Okay, and then we discussed yesterday about each of the material, about the characteristic, advantage, and also disadvantage. Okay, and then we discussed about advanced materials. Okay, advanced material is the materials that been produced for high-tech application. Okay, so this advanced material, it can be metal, it can be ceramic, it can be polymer, but it has been modified. Okay, the structure has been modified to suit this high-tech application. Okay, so for example, like yesterday we had question about nanomaterials. So this nanomaterial, it can be from ceramic. For example, titanium dioxide. It is a ceramic material. It is oxide material, but we modified the structure, become nano size, then it is categorized under advanced material. Okay. And then yesterday we discussed about structure is very important because for materials engineer, okay, we need to modify the structure, okay, regarding to the formulation, okay, and also we can modify the structure during the processing. So that means when we use certain processing, we can set different temperature, different time, or different pressure. And also during the processing, we can do like heat treatment, okay, to the materials in order to improve certain properties that we are targeting. Okay, so this is very important for us to control the structure during the processing and also during the formulation of the products. Okay, this structure will influence the properties of the materials. Okay, so we should know that what are the properties that we require, okay, to be used in certain application, and from there we modify the structure and also the formulation to produce the products. Okay. Then we discussed about ceramic materials. Yesterday we discussed about traditional and also advanced materials. Okay. There are differences between these two. Okay, let me go about traditional and also advanced. Traditional ceramic and advanced ceramic. So there are differences where I put down the notes here, but you can refer to this schematic diagram in order for you to differentiate between this conventional or traditional with advanced or ceramic. Fine ceramic. Okay, in terms of raw materials, forming, the processing, sintering, product, and also the structure. Okay, and then we have two routes to produce the ceramic products, either by using wet process or by using a dry process. Okay, so this is the powder route or dry process, and another one is the wet process. Okay, so we can use either one, depends on the targeted products, okay, that we want to produce. Okay, so today we are going to move into composite materials. So at the end of the presentation, you should be able to differentiate different types of composite materials, where I'm going to divide the composite materials into polymer matrix composite, metal matrix composite, and ceramic matrix composite. It is easier for me to divide the composite materials into these three categories. Okay, and then at the end of the presentation, you should be able to explain about the application of composite materials, where these composite materials will be used. Okay, so again, I'm showing you this figure. This is very brief about what is composite materials. Okay, to produce a composite materials, we should have fiber reinforcement, or we can, if not, the fiber is not in the form of very long, then we call it as filler. Okay, filler also normally they use to replace the fiber here, but of course fiber is very strong if you compare to the filler. Okay, because filler, it is in the form of particulate or powder. Okay, so it is not very strong. So normally in application like aircraft, aerospace application, or to produce RLT, it is like high-speed train, okay, LRT. So normally they are using fiber form, okay. But instead of fiber, we can also use particulate filler. So here, maybe the students, you can put here either using fiber or filament reinforcement or filler, okay. So this fiber or filler, we need to combine with the matrix, okay, in order to produce composite materials, okay. So if you're using fiber, of course, the fiber has high strength, high stiffness, and also low density. When we combine with matrix, okay, which is good shear properties, low density, okay.
Kok dicoret-coret kayak gini?
Halo,
Ya,
di-mute kan tolong.
ya. Okay, sudah di-mute kan. Okay, jadi when we combine this fiber or filler with the matrix, then we are able to produce composite. Okay. So what are composite materials? From dictionary, it is defined as things that made up of distinct parts. So that means products that being produced by different parts, okay, or different materials. Okay, the length, it can be nanometer to millimeter. Okay, so scientifically, this composite material is based on the idea of combining materials to utilize jointly their desirable characteristics. So that means we combine different types of materials so that we are able to use their advantages, okay, to produce a new product with new properties. Okay, so I'll show you here. the stress strain curve. If you refer to this stress strain curve, so this stress strain curve is common, where when we want to test the strength of the material, we want to if let's say kita mahu menguji kekuatan sesuatu bahan, kita akan lakukan ujian tegangan ataupun tensile test ataupun ujian bending, okay. Then from this testing you are able to get this data, okay, stress strain data. So if you refer to here, monolithic ceramic. Monolithic ceramic means mono. Mono is one, right? So ceramic without adding anything, okay. If you refer to here, this ceramic, it has a very high strength, okay, but very brittle. Okay, if you refer to strain here, it is very low strain. So that means it is very brittle. So when we combine this fiber, okay, continuous fiber in ceramic matrix. So we combine fiber with ceramic matrix, then we are able to produce ceramic composite, okay, ceramic matrix composite with good in terms of strain, okay. When you refer to the good strain here, that means the strain is increased, the percentage of strain increase. That means the product is good in terms of elasticity or good in terms of ductility. Okay, so that means it is not brittle. Okay, so this is to answer the question that I received yesterday about why we produce the ceramic matrix composite. It is basically to reduce the brittleness of ceramic material by adding this fiber into ceramic matrix. Then we are able to increase the ductility. Okay, so the toughness of this ceramic matrix ceramic material will be increased. Okay, so that is why we are producing composite materials. Okay. So the matrix, it can be either metal or ceramic or plastic. And the disperse phase. Disperse phase is the if the students still remember this figure. Okay, so the disperse phase means the fiber or filler here at this part. Okay, fiber or filler or reinforcement. So this disperse phase, either we use particulate, okay, or we use fibrous. Fibrous means fiber form, okay, or we use certain materials that exist in the platelet. Okay, platelet means it is like a layer. Okay, certain materials, for example clay, it exists in the form of platelet. Okay, so for disperse phase, it can be either we are using fiber, we are using particulate or powder, or we are using a platelet, for example, clay that exists in the platelet form. So you combine matrix with disperse phase, okay, and then you are able to produce composite materials. Okay. So this is an example of when we combine glass fiber. So glass is ceramic, right? Ceramic, one type of ceramic materials. So we produce in the form of fiber. So you can see here, the one that very long here refers to glass fiber. Okay. So the one that looks like bind the fiber, it is epoxy. Epoxy is example of polymeric matrix. Okay. So so you can see that the fiber, glass fiber, it is dispersed inside epoxy. So epoxy behave like matrix, glass fiber behave like reinforcement. Okay, so function of epoxy as the matrix is to hold or to bind the fibers together. Okay, so that it will produce a very good materials. Okay. So what is the function of matrix? The matrix is a continuous phase. Okay, it is a primary phase. Primary means it is dominant. Okay, kandungannya adalah banyak ya. Okay, jadi matrix it is dominant, it is continuous. It is used to hold the disperse phase and share a load with it. So that means it is used to hold. That means tugasnya adalah untuk memegang. Okay, memegang fasa disperse tadi, okay, ataupun fasa reinforcing tadi, supaya fasa itu tidak cabut ataupun terkeluar apabila kita kenakan load. Okay, and then it will share the load. Okay, it will share the load that been received by the composite materials. Okay, the disperse phase, it is used to it is not dominant. Okay, it is not dominant. Let's say if we want to produce composite materials, normally matrix we use like, for example, 70% or 60%. Then another balance are going to be filled by the disperse phase. Okay, like if you are using matrix 70%, the disperse phase or reinforcing phase will be 30%. Okay, so what is the function of disperse or reinforcing phase? So the name is reinforcing. Reinforcing means it is to produce strong. It is the strongest phase in the composite materials. Then it is because it is the strongest one, it is used to bear the load. Okay, when we apply load to these composite materials, so reinforcing phase will be the one that support most of the load, okay, to give a very good properties to the composite materials. So this is the function of disperse phase. And then another phase that exists in the composite material is interface. So interface is in between the reinforcement. So this is example reinforcement that we use in the form of fiber. So this is the reinforcement, and then we have the matrix. Okay, so in between these two, we have interface. Okay, so interface between reinforcement and the matrix is also important. Okay, but sometimes we don't have a good interface. Okay, because the matrix will not bind properly with the reinforcement. Okay, so in this case, normally we will see that if, let's say, the bonding between reinforcement and the matrix is not so good, then we will see there are voids exist in between these two materials and in between the interface. Okay, because matrix, sometimes this matrix doesn't like to make a bonding with the reinforcement. So that's why we will see like there are gaps, okay, exist in between these two materials. So in this case, we can say that the debonding occur. Okay, debonding occur in between matrix and the reinforcement, which indicates that the interface is not good. Okay, the interface is not good. Okay, so how to improve the interface, the bonding at the interface? Normally, we introduce like chemical or physical or mechanical bonding. So here, these are the bonding mechanism that can exist at the interface. Okay, for example, we have A here. A refers to interdiffusion. Okay, so interdiffusion, where we have molecules from matrix and also from fiber, and they are entangled. Okay, they are entangled with each other and produce a bonding. Okay, so in this case, we call it as interdiffusion bonding. Okay, and then for B, we have electrostatic addition or electrostatic bonding, whereby at matrix, for example, they have positive charge. They have positive charge, and at fiber they have negative charge. So as we know that positive and negative charges will have interaction, right? Saling suka antara satu sama lain sebab different charge, then there will be attraction. Okay, positive and negative will have interaction in between here. Then we will create bonding at the interface. Okay, and then C refer to chemical bonding. Chemical bonding is due to the chemical structure that exists at the matrix and also another chemical structure at the fiber. So this chemical structure will make a link. Okay, will make link, and then it will produce a good interface bonding. So if you compare between these four bonding mechanism, Actually, chemical bonding is the best one. Okay, it is the strongest one where it will produce interface with good properties. Okay, another one we have mechanical interlocking. Mechanical interlocking is due to the rough surface. Okay, exists on the fiber surface, and then as a result of rough surface on the fiber, the matrix will go inside the rough surface here and make a bonding. Okay, so sometimes we call it as interlocking, appear or exist at this bonding for mechanical interlocking. Okay, so these are four interfacial bonding that normally exists at the interface. Okay, this is again, if let's say there is no bonding at the interface, you will get this kind of morphology. Okay, there are voids at the surrounding of the reinforcement. And if you refer to here, example of at the left side is poor bonding, where you can see that there are voids in between the fibers, right? But if you refer to figure at the right side, okay, the addition of matrix to the fiber is good. Okay, so that means there are bondings occur in between matrix and the reinforcement. Okay. Okay, so what is the function of interface? It is used to transfer the stress from matrix to the reinforcement. Okay, so I put it here that surface treatment sometimes is carried out to achieve required bonding to the matrix. So surface treatment is referring to the chemical bonding. If students still remember that this schematic diagram, okay, so surface treatment is normally what we did to the fiber here, okay, by using chemical bonding. We introduce chemical at the fiber so that this chemical will make a bonding with matrix, and we make a bonding with the fiber. Okay, so that is the surface treatment that has been done, normally been done to the fiber. So the chemical bonding, it is like a bridge. Ianya adalah seperti jambatan di mana satu hujungnya menghubungkan sebelah sana dan satu hujung lagi menghubungkan sebelah sini. Okay, jadi dia adalah like a bridge where it connect between matrix and the fiber. Okay, so this surface treatment refers to the chemical mechanism just now. Okay, so we move to nanocomposite. Okay, what is nanocomposite? Nanocomposite is similar to the composite that I mentioned to you just now, where we have matrix. Okay, we have dispersed phase. So dispersed phase, it can be in the form of fiber, or it can be in the form of particulate filler, right? So the dispersed phase, okay, it should be in nanometer size. Okay, because it mentioned here at least one component having dimension of nanometer regime. So that means the one component here refers to dispersed phase. Okay, sebagai contoh, saya mau hasilkan composite yang berasaskan polymer matrix composite. Okay. Dan reinforcement yang saya guna ataupun dispersed phase yang saya guna adalah sebagai contoh titanium dioxide, okay, TiO2. So this TiO2 it is in the form of tube, for example, TiO2 tube. So one of the dimension of titania tadi should be in nanometer. Okay, so if let's say my titania nanotube, the length is micrometer, okay, the diameter is nanometer, okay, so I can call this composite as nanocomposite because the dimension, one of the dimension of my dispersed phase is in nanometer. Okay, so that is the definition. If let's say I'm using titania, the diameter is in micrometer, the length also is in micrometer, then I cannot call my composite as nano composite because both dimension of my titania are in micrometer. Okay, so one of the dimension should be in nanometer. Okay, so what is the nanometer regime? It is between 1 nanometer to 100 nanometer. If let's say you have titania just now, the diameter is 150 nanometer. Okay, the length is 250 nanometer. So it is out of the range. Okay, it is not micrometer, it is not nanometer anymore. Okay, because to be called as nanometer, it should be between 1 to 100 nanometer. So we can call it as nanomaterial. Okay, so when we put this nanomaterial into the polymer as the matrix, then you are able to produce nano composite. Okay. So this is example, very famous example when we talk about polymer nanocomposite. Okay, this is clay polymer nanocomposite. So clay, it exists. Clay is a ceramic material, kan? Okay, because yesterday we have discussed that when we want to produce ceramic materials, one of the example is clay. Okay, so clay, it exists in many types, or there are many types of clay. Okay, for example, we have hectorite, we have montmorillonite, we have mica also, sometimes they refer as clay. Okay, and then kaolin. Kaolin, actually there are a lot of deposit of kaolin in Malaysia. So I believe there are also kaolin deposit in Indonesia as well. Okay, so in this case, clay, it exists in the form of layer. Okay, so I skip this one first. Okay, I'll show it here. So clay, it is exists in the form of layer structure like this. Okay, it has gallery structure. So in this form, it is not a nanometer material. It is not nanometer because the width, okay, ataupun kelebaran clay ini adalah dalam micrometer dan ketebalan clay ini juga dalam micrometer. So it is not nano material. Okay. But the advantage of clay is that if you are able to split the layer, okay, or to increase the distance between the layer, okay, then now the thickness become nanometer, okay, even though the width still maintained as micrometer. Okay, so when we are able to increase the distance between the layer, then we can call it as intercalated nanocomposite. Okay, because we already intercalate, or when we are able to increase the distance, this polymer, when we want to combine with the polymer can go inside the gallery or the layer structure here and make a bonding. Okay, so in this case, we call it as one layer here as size, the thickness is nanometer size. Okay, if we are able to totally split the layer, then we call it as exfoliation process. Then here the bonding between matrix and the clay will become more improved or enhanced. Okay, because there are the surface of clay exposed to the matrix to make the bonding. Okay, so in this case, if let's say the layer is not split, okay, it's not split, then you will find out that the polymer cannot go in between the layer and make a bonding. So the polymer only can make bonding at the surrounding of the gallery or the layer structure. So less bonding occur in this micro composite. Okay, so in this case, you will see that by using modification, okay, to the processing, okay, and also by using some treatment to the clay, we are able to produce nano composite. Okay, so intercalated and exfoliated are example of nanocomposite. If you are not able to split the layer, the clay exists as it is, okay, during the processing, then you will find it exists as microcomposite. Okay, so if you compare microcomposite and nanocomposite, properties of nanocomposite is much better because the polymer can make bonding at the surrounding of each of the clay layer, and it will improve the properties. Okay, so I go back to this slide. Actually, Toyota, they already use this nano composite, okay, clay nano composite in their products. Okay, this is a very long time ago. I think somewhere in 1990 something. Okay, they already use it. So they already able to split the layer of clay to produce nano composite. Okay, and then this clay or silicate layer, they put in the nylon. Okay, nylon is one example of polymer, and then they produce timing belt cover. Okay, so they already use this polymer, clay polymer nanocomposite in their product long time ago. Okay. Okay, so in this case, if we look at the right side here, I put TEM, transmission electron microscope, where TEM is important. Electron microscope is important to see the dispersion of the clay inside the polymer. So in this case, if let's say you look at the line here, if the line are black here, it shows that the clay are stacked quite thick. Okay, but if let's say you find out the line is very thin, okay, it is not so black, it is like a very fine line. So that means the thickness or the layer is not as thick as the one that been grouped together and become like a black line here. Okay, so in this case, how to split the layer of clay is very important in order to produce nano composite. Okay. Okay, so that's about clay nanocomposite. This is a classification of composite materials if we refer to different matrices. So this is now what we are discussing. Okay, we are dividing the composite based on different matrix. We have polymer matrix composite, where the matrix, it can be thermoset. Because polymer is categorized into it is divided into thermoset, thermoplastic, and rubber. So the matrix, the polymer matrix that we use to produce PMC, it can be thermoset, it can be thermoplastic, it can be rubber. Okay, like for metal matrix composite, the matrix, it can be alloy or it can be pure metal. Okay, like ceramic, the matrix can be like other ceramic materials or also carbon. Okay, so these are the classification based on the matrix. Okay, so the matrix, the reinforcement, the function, it depends on the matrix that we use. For example, metal matrix, as we know that metal, it is not good in terms of hardness and creep at high temperature. So why we add reinforcement in metal is to increase the hardness and creep resistance at high temperature. For polymer matrix, as we know, polymer is not good in terms of stiffness, strength, and also toughness. So we add reinforcement in polymer to improve these three properties. Okay, the same thing goes to ceramic. Ceramic is brittle. So why we add reinforcement or disperse phase in the ceramic matrix is to improve the toughness, okay, to reduce the brittleness of these ceramic materials. Okay, so so this is a very brief explanation about polymer matrix composite. So when we talk about polymer matrix composite, the matrix can be anything. It can be whatever type of material, polymeric material. It can be thermoset, thermoplastic, or elastomer. Okay, it is used in aerospace, sporting goods, marine, and so many applications. The fiber that been used in polymer matrix composite, normally they are using glass fiber, carbon fiber, or Kevlar, but there are also reinforcement in the form of particulate, okay, not the fiber. Okay, for example, they are using clay just now. Okay, clay is not in the form of fiber, it is in the form of platelet. Okay, then maybe we can use silica in the form of a powder. It can be used also as the disperse phase in polymer composite. Okay, so the student, when you look at for example, if you read books, okay, they put like GFRP. GFRP stand glass fiber reinforced polymer. Okay, like CFRP, carbon fiber reinforced polymer. So you should know which one is matrix, which one is reinforcement. Okay, so GF here is the reinforcement or disperse phase, but P here, okay, P is the matrix. Okay, so you when you read textbooks or you read articles in journals, okay, when they mention about composite material, you should have idea which one is the disperse phase and which one is the matrix. Okay, so this is example of polymer matrix composite. Okay, various types of polymer matrix composite. Normally for good application or application that require high strength and high stiffness, they are using fiber. Okay, so they have glass fiber, they have carbon, they have ceramic or Kevlar fiber. Okay, so if you look at them under scanning electron microscope, you will see that the one that coming out from the matrix, so these are the fiber. Okay, the fiber. So the one that hold, yang pegang fiber ini adalah matrix. Okay, so these are how the microstructure looks like. Okay, metal matrix composite. The matrix, it can be various type of metal. For example, aluminium, titanium, magnesium, iron, copper, nickel. Okay, and then for example, aluminium. Aluminium, if they put aluminium dash SiC. SiC is silicon carbide. So SiC is the reinforcement. Okay, aluminium is the matrix. Okay, the same thing goes to aluminium dash Al2O3. Okay, aluminium oxide. So this aluminium oxide is the reinforcement or disperse phase inside aluminium as the matrix. Okay, so these are the advantages of why we produce metal matrix composite. Okay, to improve the strength, to improve stiffness, abrasion resistance, and so on. Okay. However, this MMC, metal matrix composite, it is not as widely used as PMC. Okay, because to produce MMC, you require high temperature. Okay, because to melt the metal is not easy. Okay, you need high temperature. But for PMC, polymer, so the polymer, to do the processing for polymer is quite easy because you require low temperature. Okay, so that's why it is widely being used, PMC, but MMC, it is not widely being used. Okay, so these are the explanation about MMC. Okay, where it has been used. Okay, it is used in automobile engine component, aerospace structure, turbine engine. Okay, for the place where they require high temperature. Okay. Okay, ceramic matrix composite. Because ceramic is very good or high resistance temperature material, so it can sustain high temperature. Okay, more than 1,600. It can go up to that. But somehow problem with ceramic is brittle. Okay, so common example of CMC are continuous silicon carbide fiber in glass ceramic. So glass ceramic is the matrix. Okay. Silicon carbide fiber is the reinforcement. Okay. Or zirconia toughen and silicon carbide toughen alumina. So alumina is the matrix. Silicon zirconia toughen is the reinforcement or disperse phase. Silicon carbide viscous, okay, is the disperse phase put inside alumina. Okay. Carbon and carbon-carbon composite also considered as the composite materials. Okay, they already used this carbon-carbon composite long time ago. Okay. So where this CMC been used, it is used in the application where it require very, very high temperature, okay, and severe stress application. Okay, so it is used in automobile, aircraft gas turbine engine. Okay, so this is where this CMC being used, very high temperature with good performance. Okay, so when we produce composite materials, there are terminology where students, when students read about composite materials, sometimes they like to use hybrid composite. So what is hybrid composite? Hybrid composite is where we combine the reinforcement normally. Okay, we combine the reinforcement. Let's say here we have fiber A. Okay, fiber A, maybe glass fiber. We mix with polymer, for example. So we produce glass fiber reinforced polymer. Okay, but glass fiber, it has a disadvantage. It has advantage. For example, it is cheap, but low properties. Okay, and also it is heavy, berat. Ya, dia berat sebab density dia it is about 2.5 compared to carbon, for example, the density is about like 1 point something, so it is lightweight, high properties, but it is expensive. So we want to have properties, composite materials in between, okay, in between properties of glass fiber and carbon fiber. So what we did, we combine these fibers. Okay, so it can be like in this fiber, normally when we want to produce this composite material, we purchase the fiber in the form of mat. Okay, dalam bentuk kepingan. Okay, so the fiber is coming dalam bentuk kepingan. So when we want to produce this hybrid composite, either we purchase mat fiber where it is already been combined. Okay, so it is already been combined of fiber A and fiber B inside this mat. Or to make it easier, we can also combine fiber A and fiber B, or glass fiber, let's say one layer of carbon fiber, another layer of glass fiber, and then we mix again with carbon fiber. Okay, then we stack at different what they call different amount of fiber A and fiber B. Okay, then we stack and then we impregnate with the zinc. Okay, so in this case, when we combine these different disperse phase, then we are able to produce a hybrid composite. Okay, so if you still remember, I mentioned to you about clay nano composite. If let's say we want to produce hybrid nano composite, so clay you can combine with titania nanoparticles, for example. So you produce hybrid nano composite. Okay, because you are using two different types of nanomaterials in the matrix to produce hybrid nano composite. Okay. So classification of composite materials can be divided also based on either if you are using reinforcement in the form of fiber, or if you are using reinforcement in the form of particulate, okay, particle or powder. So if you are using in the form of fiber, the fiber can be random orientation. It can be unidirection. That means the fiber it is in the form of straight, okay, one direction. or it can be the fiber in two direction. Let's say 0 degree and 90 degree. Okay. If you're using particulate, you can have also random orientation and also particulate where you can align the particulate in one direction. Okay. For example, in this case, like if you have particulate in the form of needle shape. Okay, needle shape, it is like a long needle, jarum ya, dalam bentuk panjang-panjang seperti itu. Then we are able to align the needle shape in one direction. Then we produce a particulate composite in unidirection. Okay, so we can also classify composite material based on this category. Okay, either we classify based on different metrics, or we can classify based on different geometry of reinforcement. Okay, so these are the schematic to show that the different composite just now. If let's say you are using particulate and then the arrangement is random, then you will get this kind of composite materials. But if you are using discontinuous fiber, so that means it is short fiber. However, we are able to align in one direction, then we are able to produce this composite. Okay. If let's say discontinuous fiber but random, this is in this, you are able to produce composite in this kind of random orientation. Okay, this is example of continuous fiber, long fiber, and align in one direction. Okay, so in this case, you will produce composite that has isotropic properties or anisotropic properties. Okay, isotropic properties means that the properties in all direction of fibers are similar. Okay, so let's say if you have particulate filler here, random orientation, if you cut your sample at 0 degree, okay, and you cut sample at 90 degree, when you do the testing, you pull the sample, you will get similar tensile strength. Okay, the same thing goes to C. You have discontinuous fiber and random. If let's say you cut your sample in 0 degree, cut sample in 90 degree or 45 degree, you do the testing, the properties are slightly similar. Okay, because the fiber are random orientation. So in this case, for A and B, you will get composite material with isotropic properties. Okay, but for B and D, because the fiber are aligned in one direction, if you cut fiber in 0 degree, okay, and compare with 90 degree, okay, the strength are different. Okay, so in this case, for B and C, you will get composite material with anisotropic properties. So it means that the properties are not the same in different direction. Okay, so these are these two terminology, isotropic and anisotropic properties, which are widely been used. Okay, when we refer to these composite materials. Okay, so this is natural composite. If you look at plant, okay, pokok ya, pokok. So pokok adalah salah satu contoh natural composite because pada pokok we have cellulose, hemicellulose, and lignin. Okay, cellulose is the strongest part in the plant. Okay, so cellulose, if you refer to the definition of composite material, it is similar like reinforcement or disperse phase because it is the strongest part in the composite material. So cellulose, it is the reinforced phase. Lignin behave as adhesive, okay, where it will tie the components. So lignin behave as a matrix. Okay, so we have reinforcement and the matrix. So wood is example of natural composite. Okay, and hemicellulose here. Hemicellulose is located in between cellulose and lignin. So hemicellulose behave like a interface. Okay, interface. So This is a very good example of a natural composite. And another one is bone. Okay, bone, tulang, ya, tulang dalam badan kita. So we have hydroxyapatite reinforced collagen. So hydroxyapatite is the a reinforcement. Collagen is the matrix. So bone is one example of natural composite. Okay. Okay, why we produce composite materials? Because we want to improve the properties of the monolithic material, or means that one single material. Okay, that is monolithic material. So for example, if you look at pole, ya, tiang elektrik ataupun tiang apa tu, telekomunikasi. Okay, so previously they are using wood, right? Wood. And then they move to steel, and then they move to concrete, and then now actually in Western country they are using polymer composite, okay, where they use glass fiber with resin. Okay, if you can see this figure here, even though it is too small, but there is one man here where he can hold the pole. Okay, no need for them to use crane, okay, to install the pole. Okay, by using human 2 or 3%, then we can install the pole. Okay, if let's say we are using steel pole, it is very heavy. Like concrete pole, also very heavy. Okay, so we need to have the installation is very expensive, where we need to find the crane, okay, to install the pole in the construction site. Okay, so when they are using polymer composite, they move into polymer composite, it do not corrode. Okay, it won't rust. Then it require no preservative. If let's say we are using wood, we need to preserve to make sure that it not been attacked by termites ataupun anak-anak, ya, tidak diserang oleh anak-anak. And then it is lightweight. Okay, then low cost for installation. Okay. Okay, I want to attract your attention to the use of polymer matrix composite in aircraft. Okay, this is in Boeing 787. If the student refer to the dark blue color, okay, so it put here carbon laminate. Okay, carbon laminate, dark blue color. The slightly blue here refers to carbon sandwich. So both are carbon composite. Okay, carbon reinforcement in polymer matrix. So most of the parts here, about 50%, they are using composite materials. Okay, so now they are moving towards composite, polymer composite. Even the steel, they are using metal part like aluminum and titanium. For parts that require high temperature, so they are using metal and also ceramic. Okay, but when they change to polymer composite structure, they are able to save the weight. Okay, reduce. That means they reduce the weight. Okay, weight saving of 10 to 60% if you compare to the metal. Okay, so when they're able to reduce the weight, this aircraft require less fuel. Penggunaan bahan bakarnya akan berkurangan. Okay, dan apabila bahan bakarnya berkurangan, dan ianya menjimatkan. Okay, dan juga apabila kita kurang bahan bakar dan carbon emission, carbon yang dilepaskan ke environment juga akan berkurangan. So this is very good for environment. Okay. Okay, if you refer to the automotive, the same thing also happen in automotive. For example, in car, because car, they use petrol, right? They use fuel. So if we are able to produce a lightweight structure, then we are able to save consumption of fuel. Kita dapat mengurangkan penggunaan bahan bakar. Okay, jadi if students read articles in journal, normally they like to use natural fiber now, okay, as the reinforcement. For example, they use flax, hemp, okay, sisal, okay, as the reinforcement in polymer, okay, in polymer. So why they are using natural fiber? Because of the price, okay, low cost. natural fiber exists naturally, where the price is lower if you compare to synthetic fiber like carbon or glass fiber. And then natural fiber light in weight. It is ringan, sangat ringan. And then it is renewable resources. That means it is relates to the environment. Okay, so it is good. So that's why in automotive industry, they are moving towards using natural fiber. Okay, so if you look at here in automotive, okay, the use of polymer composites are increasing from year to year. Okay, metal composite, the one that light blue color, still increase, but the percentage of increment is not as high as metal as polymer matrix composite. Okay. Ceramic matrix composite also been used, but the amount is very minimum. Okay, it is mentioned here that if we are using fiber, reinforced plastic composite, we are able to produce lighter components, okay, 25 to 35% lighter compared to if they are using steel parts, okay. So just imagine when we are able to reduce the weight of the component. So it is stated that for every 45 kilogram mass reduction in the vehicle, it will increase fuel efficiency to 2 to 3%. So it can reduce the amount of fuel that been used. Okay, when we able to reduce the fuel being used, then we can results to low emission, low carbon emission. Kurang pelepasan carbon lah to the environment. Okay, so this is an example. If let's say chassis, okay, chassis structure of the automotive produced by carbon fiber reinforced polymer. CFRP means carbon fiber reinforced polymer. It is very lightweight. Okay, in fact, two ladies, okay, can basically hold, okay, or uplift this component easily. Okay, so it is light in terms of weight. Okay, so these are example of where they are using natural fiber in the structure, so you can go through. Okay, this is another example where they are using hemp fiber. Okay, hemp fiber. If the students want to know more about hemp, you can just Google hemp, and then it will show that the plant is just like knaf plant. Okay, so they obtain this fiber from hemp, and then they produce in the form of non-woven mat. Okay, and then impregnate with the resin, okay, polymer resin. Okay, they put the polymer resin into this non-woven mat, put inside the mold, and we are able to produce the this door, okay, door. And then after that, they will do the finishing process and produce the door for the car. Okay, so this is example of use of natural fiber in automotive. Okay, so this table is just to show to the student that if you want to compare between natural fiber with glass fiber, okay, glass fiber here. So all the fibers that I put here, all the natural fiber, flax, hemp, jute, rami, all are natural fibers. Then try to compare with glass fiber. Okay, the first thing is that the density of natural fiber is very low. Okay, so you look at here, the density all 1 point something. Compared to glass fiber, 2.55 gram per centimeter cube. So it is very heavy. Okay, glass fiber is very heavy. The tensile strength. So the tensile strength, it is reduced. Okay, natural fiber, it is not as good strength if you compare to e-glass. Okay, the same thing goes to modulus, but there are certain like flags here. The modulus is quite good, comparable to e-glass. Okay, another advantage is specific properties. Specific properties is that when you divide the strength, for example, or the modulus, okay, with the density. So here, if you refer to here, most of the this natural fiber composite, it shows better specific properties if you compare to the E-glass. Okay, so because if let's say E specific properties, modulus specific properties, so E here you divide with the density, then you can get this value. Okay, so advantage of natural fiber composite is that the density is very low. So when E you divide with the low density, then you will get high properties. So this is the advantage of natural fiber composite. Okay, and then the price also very cheap if compared to the glass fiber. Another problem with natural fiber, okay, is the moisture absorption. Okay, moisture absorption, where natural fiber like to absorb moisture. Okay, so it will cause problem during the processing. Okay, because when this natural fiber absorb moisture, just imagine if you do the processing to produce composite, polymer composite, for example, at the processing is at 150 degrees Celsius. So moisture from natural fiber will be evaporate, right, at 100 degrees Celsius. So during the processing, the moisture will be evaporate and it will leave the bubble or voids inside the structure of composite material. So this is disadvantage of natural fiber if compared to the synthetic fiber. Okay. This is the application of polymer composite in electronic. I think that maybe most of you know about printed circuit board. Okay, printed circuit board, if you open any of the electronic component, they have this PCB, printed circuit board. It is like a board, rigid board, green in color. Okay, so if the student go inside, see what is inside the component inside the PCB, actually they are using glass fiber, okay, reinforced epoxy as the core, okay, the core inside the board, okay, because it will give a stiffness to the board, okay, because during the PCB process, to mount the component, okay, they have equipments where they need to punch the component, so we need something that's stiff in the middle of the board, so that's why they are using woven E-glass reinforced epoxy. Okay, and then to mount or to connect component on in the electronics products, normally they are using solder. Okay, solder interconnection. So solder is metal based. Okay, metal based. They can also use conductive adhesive. Okay, to mount the chip, for example, here on the board. Okay, on the substrate here. So this conductive adhesive, it can be a combination of metal with polymer. So it is a polymer composite. So metal, when we load at a certain amount, it become conductive, okay? Because when you load certain amount, the metal will touch each other and produce conductive composite, okay? So in this case, this is another example of polymer matrix composite used in electronic products. And also, they use polymer matrix composite as underfill in electronic products. Okay, we have printed circuit board, PWB or PCB, or the same thing. Okay, PWB refers to printed wiring board, but then it is the same with printed circuit board, the one that green in color. Okay, so we want to attach IC on the board, so we can use solder. If let's say we don't want to use conductive adhesive here, okay, we can use solder. So in this case, this figure shows that they are using solder. Okay, during the application, because when we use this product for electronic application, we are exposed to the temperature. So IC will expand less. Printed circuit board here will expand more because it produced from polymer composite. Then we have component solder, which is in the stress form, okay, stress, because of the thermal mismatch, okay, because of the difference in coefficient of thermal expansion. So what they did, they put the underfill. So this underfill, it is made up from silica, fill, epoxy. So this is example of polymer composite. Okay, this is to show to the students that there are many components in electronic products where they are using polymer composite. Okay. This is for food packaging. For food packaging, as we know that they are using plastic to wrap the food. So there are 3 types of category for food packaging. They call it as nano reinforcement packaging, active food packaging, or smart food packaging. Okay, smart food nano system packaging. So inside the plastic, so they put various additive. Okay, for example, or nano reinforcing packaging, they put nano clay inside, they put carbon nanotube to improve the performance of the plastic packaging. So it is composite packaging. And then for active food packaging, also they add something inside the plastic packaging, okay, to improve the properties of the packaging. Okay, the same thing also to smart food packaging. So this is active food packaging. Active food packaging means that the packaging, it is the function is basically to preserve the food inside. Okay, so active food packaging means that it will have a good interaction between food and packaging and also the environment. Okay, so in this case, they add various type of active compound in the plastic formulation to produce composite plastic. So one of the example, if they are using nanoparticle in the food packaging, okay, to produce this active food packaging, where by using this active food packaging, it will avoid the food from deteriorate. Okay, that means untuk mengurangkan kerosakan makanan lah. Okay, so they are using active food packaging. One example of nanoparticles that can be used, normally they add a clay inside. Okay, clay inside the formulation. So this is smart packaging. Smart packaging is that we able to attach the this sensor at the food packaging. This sensor can be connected to the apps in our handphone. So by scanning this sensor, we know that the food inside is still good or not. Okay, because now we are normally refer to the labeling at the food packaging, okay, used by dates. Okay, for example, if let's say it is stated here that the dates for the food to expire maybe next week, for example, next week. But sometimes the food is already expired due to the poor storage during the transportation. Okay, so if let's say we purchase the food, even though the date is still not expired, but the food is still, it is already damaged. Okay, cannot be used anymore. Okay, so in this case, it will cause food poisoning. Okay, but sometimes even though the date is expired, but the food is still okay. Okay, so in this case, they produce this smart packaging where they put polymer composite sensor here at the package inside, where it can be detect by using our handphone to know that the food is okay or not. Because actually the food, it will release gas, okay, in the process to deteriorate, dalam proses untuk bila kita simpan, okay, makanan itu lama-lama akan jadi busuk ya. Dalam proses untuk dia menjadi rosak itu, dia akan mengeluarkan gas, contohnya methane. So this methane will be detected by the sensor, okay, then at certain percentage of methane that been released, then we know that the food is already been damaged. Okay, so this is what they did to the packaging. Then call it as smart packaging. Okay, and then in medical application, there are various way. Okay, there are various application where we can use this polymer composite in medical application, okay, like drug delivery, scaffold, implant, sensor, and so on. So polymer that normally been used, which is good for medical, it is not toxic, is PMMA. Okay, PMMA, and then polyurethane is also good. So what they did normally, they produce component or implant based on this material. Like polyurethane, they are using first artificial heart, okay, in 1960s, very long time ago. They used to produce artificial heart by using polyurethane, okay. And then we need also biodegradable polymer or biodegradable polymer composite inside for biodegradable application. For example, if let's say the surgeon do the surgery, okay, then they use sutures ataupun benang, benang untuk jahit tempat luka. Okay, if let's say it is inside our body, okay, the sutures ataupun benang tu, kita tidak perlu lakukan second pembedahan untuk mengeluarkan benang tersebut. Okay, because the sutures ataupun benang itu akan degrade sendiri dalam badan. So dalam kes itu, kita perlu menggunakan polimer ataupun polimer komposit yang tidak toksik kepada badan kita. Okay. So there are a few types of polymer that can be used. For example, PGA, polyglycolic acid. It is already been used as sutures for this biodegradable purpose. Okay. Okay, this is just to show to the students that study development of materials for medical is not easy. Okay, because first we need to develop. Let's say if you want to produce a new composite as implant material. Okay, now the implant, for example, they are using metal base. Okay, sebagai contoh, sekiranya berlaku kemalangan dan mereka akan memasukkan metal ataupun titanium di dalam badan. Tetapi dalam kes ini, katalah kita nak developkan satu composite material based on polymer composite, then we want to produce it as implant in our body. So we need to do research in terms of how to produce this implant material with good properties. Okay, so this research will take normally 7 to 10 years to complete. Then after we already fulfill all the criteria, we need to do in vitro testing. Okay, in vitro testing means to identify either the material that we develop is toxic or not to cell. Okay, to cell. So in this case, we put our material in the petri dish. Okay, we put the cell in the petri dish, and then we put our material. If let's say our material is toxic, and then the cell will die. So that means our material is not good for cell. Okay, it cannot be used for as implant in the body. Okay, so but if let's say the material, composite material that we develop is good where it is not toxic, then we go to the next step. The next step is that we need to put our material that we develop in animal. Okay, in animal. So normally we use in small animal, then after that go to big animal. So small animal we put in rabbit or we put in mice, tikus. Yeah. So kita lihat kalau katalah tikus itu mati for certain time, then we cannot. So that means our project is not successful because the material is toxic. And then after we success in small animal, then we go for big animal. For big animal, normally kita akan menggunakan kambing ataupun menggunakan monyet. Okay. So all this testing that we do in vivo implantation, it should go tissue, viability, histology, inflammatory, all this testing. Okay. If let's say we are successful here, the next step is to put inside human. Okay. So we put inside human, then if it is successful here, that means we already success in developing new materials for medical application. So these are the steps that need to be go through if we are developing new materials for medical application. Okay, just to share with you that they are using different types of materials, okay, in hip joint replacement. So hip joint replacement, they are using, for example, metal, okay, metal, but at certain parts they are using polymer, okay, to join between pelvis, for example, with the metal implant here, okay. So this is where people can develop so many materials, okay, to replace the use of metal here or the use of polyethylene here, okay, sometimes to reduce cost and also to give a better performance, okay. This is another example where they use ultra high molecular weight polyethylene as what they call liner, okay, liner between cup, okay. They are using a metal shell here, okay, and then they use ultra high molecular weight polyethylene, and after that this metal parts will be joined together, okay. Ultra high molecular weight polyethylene, it is good in terms of wear and tear properties. It is not easily being wear because here when we put at this joint, it involves a lot of friction, okay, movement. So ultra high molecular weight polyethylene is very good in this sense, okay. Also they are using at knee, okay, knee. Kalau ada orang tua-tua yang sakit lutut, okay, then the surgeon will put ultra high molecular weight polyethylene here, okay, because it is very good. It will not easily been what they call due to the friction. It is not easily it is not exposed to high wear and tear. Okay, wear and tear of this material is very good. Okay, and also bone cement. It is like example of composite material. They are using, they are putting glass ceramic or titania inside this PMMA, okay, to improve the performance of cement, okay, because this glass ceramic, titania, they have bioactive. It is bioactive particles. It is easily to make a bonding to the tissue at the surrounding, okay. So here they are using for cement, they are using polymer composite, adding this filler, bioactive filler inside PMMA. Okay. Okay, the last one I just want to share with the student is that when later on, if let's say you are working as an engineer in the industry, let's say you are working as product engineer, you need to select good materials for certain application, okay, because as you see why Titanic tragedy for Titanic and also Challenger, the one that I shared with you in the first slide yesterday, it is due to the wrong material selection. So when we want to select good materials for certain application, normally we need to go through all this process. There are 4 stages here. First, you need to identify the design requirements. So that means to be used, for example, as implant material in our bone. So we should have good strength. Okay, for example, good. It is not toxic. Okay, it is. It should have good compression strength. It should have a good stiffness and so on. So all the criteria or the properties that are important, you should list down. Okay, and then you should screen off the function, okay, by using the constraint properties. So to screen off, you can use this SB chart. Okay, so this SB chart, remember just now we already list down all the important criteria. For example, one of the criteria is strength. And another example is service temperature. Okay, so service temperature, let's say you want to produce component for engine. Okay, you want to produce component for engine, you require strength and you require service temperature. Okay, let's say the product is going to be used at 1000 degrees Celsius. Okay, 1000 degrees Celsius is the limit. This is the minimum temperature. Okay, and then the strength that you require to be used for engine, for example, minimum is 100 megapascal. Yeah, so 100 megapascal. So the materials that you are able to select is basically the material at the upper side, okay, upper right side. Okay, so these are the materials that have fulfilled the criteria of minimum of 1000 degrees Celsius and minimum of 100 megapascal. Okay, so all the material at the left side and the bottom one you can eliminate. Okay, so you just consider all the material that at the top right side. Okay, so this is the screening process. And then later on, you rank your candidate. Okay, you rank the candidate based on the criteria, for example, based on the cost, okay, based on the design flexibility. Is it easy for you to process, or is it harm to the environment? So these are the criteria or the selection or the stages that you should consider when you want to do material selection later on when you work in the industry. Okay. So this is very brief about a trip to industry, composite industry, where they produce a component for this unmanned aerial vehicle. Okay. These are the composite structure that been used in producing dome. Okay, dome here for in Putrajaya, in Kuala Lumpur. There they have moss dome kubah, ya, dibuat daripada composite. So it is lightweight if you compare to the concrete dome. Okay, then they are producing train. Okay, train, the lightweight light LRT, light transit a train. It is like a high-speed train. They're using polymer composite, glass fiber, and epoxy. Okay, the high-speed boat also they are producing from this glass fiber composite. Okay. Okay, that's all for today. Okay, so I open for question. If you have any questions, so just feel free to ask. I try to answer the best as I can. Okay.
Okay, thank you very much for your clear and detailed lecture, Professor. Okay, teman-teman, please provide your question related to composite materials. Dipersilakan, raise your hand or write your question in chat room. Boleh berbahasa Indonesia. Silakan. Ayo, jangan malu-malu. Siapa? Farid? Ya, silakan Farid.
Terima kasih sebelumnya, Bu. Perkenalkan, nama saya Muhammad Farid Alwi dengan NIM 2297. Di tabel Properties of Glass and Natural Fibers kan ada density-nya, Bu. Yang E-glass, flex, hem, jute, remi. Itu di atas 1 semua. Jadi sedangkan density air kan 1, Bu. Nah, di bawah tadi ada pembuatan boot. Apakah fiberglassnya bisa tenggelam dong, Bu? Jadi ya, Bu. Karena density tinggi daripada air.
Ya. Okay.
Terima kasih.
Okay. Ya, terima kasih Farid. Kalau kita lihat density glass 2.55 kan, density natural fiber 1 point something lah, okay. Dan kalau kita letak glass fiber ini di dalam air, dia akan tenggelam sebab density-nya tu lebih daripada density air, okay. Tapi natural fiber ini dia akan sebab dia ringan, tetapi kalau kita lihat density-nya tu lebih kurang dengan density air. Cuma disebabkan natural fiber ni ada tendensi untuk absorb moisture, untuk absorb air. Jadi lama-kelamaan bila kita letak natural fiber ni dalam air, lama-lama dia akan jadi tenggelam jugalah. Tetapi lambat sedikit. Okay, lambat sikit sebab densitinya tu kurang daripada air. Kalau kita lihat contohnya kayu, ya, kenapa kayu tu terapung di dalam air kan? Sebab densitinya tu kurang daripada air atau lebih kurang sama daripada air. That's why kita nampak dia macam di tengah-tengah air, ya, kedudukannya tu kan. Sebab densitinya lebih kurang sama dengan air dan dia tak tenggelam. Kemungkinan di dalam itu ada rongga-rongga. Di dalam kayu itu ada rongga-rongga menyebabkan walaupun dia absorb moisture, absorb air, tetapi masih lagi berada di atas, tidak tenggelam. Sebab dia punya struktur dalam tu ada rongga-rongga lah, menyebabkan dia masih lagi terapung. Okey.
Okay. Atau ada kemungkinan juga karena dia kan tercampur juga dengan matriks yang punya density lebih rendah ya, Prof. Karena kan seperti dia kan tidak sendiri dipergunakan untuk misalnya untuk kapal ya, dia kan ada matriksnya juga yang mungkin jadi densitas campurannya juga jadi rendah ya antara itu.
Ya, betul.
Terima kasih banyak, Bu.
Ya.
Oke. Siapa lagi? Silakan. Nih, ada chat ya. Saya bacakan, Prof. Assalamualaikum dan selamat pagi, Ibu. Perkenalkan nama saya Dea Amanda Sari dengan NIM 22013. Izin bertanya terkait nanokomposit, Bu. Apa yang menjadi tujuan dibuatnya nanokomposit, serta apakah ada batasan jumlah komponen yang ditambahkan untuk membuat nanokomposit? Apabila melebihi batasan yang ada, apa pengaruhnya terhadap nanokomposit yang terbentuk? Terima kasih. Jadi, apakah setiap komponen itu ada batasan jumlahnya, Prof? Matriksnya atau pengisinya. Batasan jumlahnya berapa persen dia seharusnya, Prof?
Ya. Okey. Terima kasih Dia Amanda. Okey, untuk nanokomposit tujuannya adalah untuk menghasilkan satu bahan yang bagus sifatnya. Okey, itu tujuan kita hasilkan nanokomposit, di mana salah satu komponen di dalam nanokomposit itu saiznya adalah nanosize. Okey, jadi bila nanosize, bahan itu terlalu kecil, jadi kita akan mempunyai banyak ikatan yang akan terbentuk di antara matriks dengan partikel kita tu ataupun fiber yang kita guna tu sebab saiznya terlalu kecil. Okay? Jadi surface area-nya tu adalah besar untuk berlaku ikatan di antara matriks dengan reinforcement. Jadi ia akan menghasilkan satu bahan yang bersifat kuat. Okey, jadi itu adalah tujuan kita menghasilkan nanokomposit. Dan jika kita lihat peratusan komponen yang ditambah itu adalah sedikit bila kita menggunakan nano. Seperti yang saya bagi contoh semalam, kalau kita gunakan silika micron size, kita perlu load 40% untuk dia mencapai satu kekuatan tertentu. Tetapi bila kita menggunakan silika yang nano size, kita cuma perlu load mungkin 2% ataupun 3% sahaja dan dia akan mencapai properties yang sama. Okay? So cuba bayangkan kalau katalah kita masukkan silika 40%, okay? Silika itu berat. Okay? Kalau kita lihat tadi glass fiber, ya, dia banyak menggunakan silika, densitinya 2.55. Jadi kalau katalah di dalam komposit kita masukkan 40% silika, density 2.5, so dia akan menghasilkan polimer komposit yang berat. Tetapi bila kita menggunakan nanosilika, kita load 2% sahaja. Okay? Dan kita capai properties yang sama. So kita akan menghasilkan polimer nanokomposit yang kuat dan juga ringan. Okay. Sebab itu jika kita lihat batasan dia tu memang ada, cuma untuk nanokomposit percentage dia tu sedikit. Percentage nano yang kita guna tu adalah sedikit. Kalau kita tambah banyak nanosilika di dalam komposit, dia tidak ada guna juga sebab bila terlalu banyak kita masuk nanosilika, dia akan menyebabkan silika nanoparticles tu tadi akan agglomerate. Dia tak akan disperse cantik. Okay. Jadi kalau kita masukkan terlalu banyak, tak guna sebab dia akan menurunkan properties nanocomposite tersebut. Okay. Jadi yang cantiknya kalau pelajar lihat di dalam kajian yang dilakukan, bila pelajar baca artikel dalam jurnal, biasanya untuk nanocomposite reinforcement yang dimasukkan cuma antara sekitar 2% sehingga dalam 5 atau 6% saja. Okay, tidak banyak. Kalau micron size, biasanya kita akan masuk sehingga 30%, 40%. Okay, untuk capai properties yang dikehendaki. Okay. Okay, dia?
Oke, Prof. Makasih ya, Prof.
Okay.
Cukup jelas ya, Dea ya. Silakan. Yang lain, siapa ini? Ada Ami, Aditya, Stephen. Silakan, siapa yang mau?
Hari ini kurang sedikit pelajarnya, ya? Prof?
Iya. Tadi sampai juga 90-an, ini 76. Memang jaringan juga kurang bagus sekarang, Prof. Di saya pun harus pakai tethering ini, nggak bisa pakai wifi.
Oke.
Silakan teman-teman.
Izin Bu, saya ingin bertanya Bu.
Ya, Prima, silakan
Ya.
Prima.
Ya Bu, izin Bu. Perkenalkan Bu, nama saya Prima Tafrinaldi dengan NIM 22102. Tadi Ibu ada menyebutkan bahan konstruksi pesawat itu ada utamanya itu karbon laminate sama karbon sandwich. Perbedaannya itu apa Ibu?
Okey, terima kasih Prima. Okey, saya tidak jelaskan dengan detail sebab masa kita singkat kan. Tetapi okey, bezanya kalau carbon laminate dia menggunakan karbon dalam bentuk stacking. Okey, carbon fiber di-stackkan antara sesama carbon fiber ataupun carbon fiber di-stackkan dengan aluminium layer di luar. Okey. Jadi dia punya stackingnya tu adalah carbon fiber yang padat. Okey, kalau carbon sandwich, dia akan menggunakan carbon layer, tetapi di tengah tu dia akan menggunakan material yang low density. Contohnya honeycomb structure ataupun foam. Okey. Jadi di sekitar pesawat di sekitar sayapnya, okey, sayap banyak dia menggunakan carbon sandwich supaya memberi properties yang ringan, properties yang bagus dan ringan. Okey. Jadi kalau Prima cuba Google cari sandwich structure. So sandwich structure ni dia akan letak satu layer dalam kes ini carbon dan di tengah tu dia akan letak sama ada honeycomb. Normally dia akan menggunakan honeycomb structure. Jadi dia akan bagi satu structure yang sangat ringan dan juga kuat. Okey. Jadi saya selalu bawa pelajar melawat industri pesawat di Malaysia ini. Mereka akan gunakan honeycomb yang daripada aluminium. Okey, honeycomb tu dia punya structure dia macam sarang laba-laba itu. Sarang laba-laba. So structure tu sebenarnya sangat kuat. So dia akan letakkan honeycomb metal, lepas tu dilaminatekan dengan carbon fiber di luar. Dan dia akan menghasilkan satu structure yang sangat kuat lah. Okay. So perbezaannya adalah kalau laminate tu semuanya adalah padat. Okay. Dia tidak ada honeycomb di tengah. Dia semuanya adalah carbon layer dilapisi.
Lapis-lapis ya.
Dilapis-lapis, okay, dan menghasilkan satu struktur yang kuat dan juga sedikit berat, padat. Okay. Tetapi untuk sekitar sayap itu dia banyak menggunakan karbon dilapisi di tengahnya dengan honeycomb structure. So kita panggil sandwich.
Terima kasih Bu.
Ya, sama.
Oke, terima kasih Prof. Udah cukup ya, Prima ya. Megan, silakan Megan. Megan ini rasanya tertarik mau sekolah ke USM sepertinya dia ini.
Ya. Kemarin pun bertanya soalan. Okey, dipersilakan semua kalau siapa mau belajar di sini, bolehlah hubungi saya.
Baik Ibu, Assalamualaikum. Selamat pagi menjelang siang Ibu. Sebelumnya perkenalkan nama saya Megan Cecilia Farel dengan NIM 22008. izin bertanya menggunakan bahasa Indonesia ya, Bu. Nah, jadi kita telah mempelajari tentang komposit, Bu. Yang mana komposit itu tadi ada MMC, CMC, dan PMC tadi, Bu. Nah, seperti dengan tentang materi-materi yang telah lalu, yang telah disampaikan dosen sebelumnya juga, bahwa kaca itu dapat juga dikompositkan. Seperti contohnya itu kaca anti peluru, Bu. Yang mana itu kan digabung, bahannya itu tergabung dari kaca dan polimer. Nah, jadi pertanyaan Megan ini, Bu. Apakah cuma MMC, PMC, dan MMC, PMC, dan CMC, Bu? Sedangkan ada loh pengaplikasiannya tuh dari kaca tadi. Kenapa kita tidak mempelajari tentang kaca ini tadi ya, Bu? Seperti itu. Apakah karena pengaplikasiannya yang sedikit, atau memang tidak penting, atau bagaimana ya, Bu? Atau memang tidak ada gitu? Seperti itu, Bu.
Okey, maksud soalan Megan ini, komposit yang berasaskan kaca sebagai matriks, ya?
Iya, Bu. Seperti itu.
Okey. Ada semasa kita berbincang pasal CMC, ceramic matrix composite, ada juga saya sentuh tentang kaca. Sebab kaca ini adalah di bawah kategori ceramic material. Cuma perbezaan kaca dengan ceramic material yang lain adalah kaca ini amorphous. Rantaiannya tu amorphous. Manakala ceramic material yang lain adalah crystalline. Crystalline maksudnya dalam rantaian dia tu dia ada rantaian yang tersusun, menyebabkan dia crystalline. Tetapi kaca rantaiannya dia punya strukturnya adalah amorphous. Jadi disebab itu dia menghasilkan kaca yang terhasil adalah transparent. Transparent maknanya kita boleh see through lah. Disebabkan dianya adalah amorphous material. Jadi bila amorphous materials, bila kita lihat kaca dan juga bahan seramik yang lain, dia brittle. Brittle maknanya dia rapuh. Rapuh. Ada sesetengah aplikasi yang memang memerlukan penggunaan kaca. Dan apabila dia memerlukan penggunaan kaca, dan kita akan masukkan reinforcement di dalam kaca tersebut untuk menghasilkan komposit. Cuma Megan perlu ingat penggunaan komposit material ini, ceramic komposit material ini, dia cuma boleh digunakan dalam sesetengah aplikasi sahaja disebabkan sifatnya yang brittle tadi. Disebabkan sifatnya yang brittle. Masih lagi boleh digunakan contohnya dalam pesawat, digunakan sebagai cermin kan. Cermin masih lagi boleh digunakan, tetapi untuk improvekan sifat brittlenya tu dan pada masa yang sama sekiranya kita masukkan partikel di dalam kaca, kita tidak dapat menghasilkan produk yang transparent. Dia sudah menjadi kacau kan, dia tak jadi transparent dah. Jadi untuk sesetengah aplikasi, contohnya kaca tu tadi, kita tidak boleh menghasilkan dia komposit. Jadi mungkin mereka akan laminatekan, dia akan lakukan sesetengah treatment kepada kaca tu supaya dia kuat dan dia tidak cepat pecah. Jadi bukan komposit daripada segi itulah kalau kita perlukan transparent. Tetapi untuk aplikasi contohnya macam enjin ataupun aplikasi yang memerlukan suhu yang tinggi, mereka menggunakan ceramic material tapi bukannya glass. Sebab glass ini masalahnya yang paling pentingnya adalah dia brittle. Brittle dia tu adalah lebih teruk daripada seramik lain yang crystalline. So ada juga aplikasi kaca di mana masih lagi digunakan. Dianya tergantunglah kepada di mana kita nak guna ya. Saya pun tidak ada idea nak bagi contoh banyak untuk aplikasi kaca, tetapi masih lagi digunakan. Cuma tadi Megan ada sebut untuk apa ya tadi, kaca dengan
izin Bu, kaca anti peluru, Bu.
Anti peluru. Anti peluru. Kaca anti peluru. So mungkin kaca anti peluru tu saya cuma saya tak pasti kaca anti peluru tu adalah dia kaca komposit ataupun kaca yang dibuat treatment bagi kaca tu lebih kuat, lebih tahan terhadap peluru yang datang. Ya. Cuma tak pasti sama ada itu komposit ataupun kaca yang dia telah dibuat heat treatment. Okey.
Oke, baik Bu. Terima kasih. Izin Bu, berarti kenapa kaca ini tidak terlalu dimasukkan ke dalam komposit karena sifatnya tadi yang rapuh ya Bu?
Nah, ini rapuh, dia rapuh. Dan juga kaca macam tadilah yang saya sebut, bila kita perlukan sifat transparansinya itu, bila kita masukkan particles di dalam tu, dia akan mengurangkan sifat transparansinya tu.
Baik Ibu, terima kasih banyak Bu.
Ya.
Komposit kan memang harus ada bahan tambahan dan itu nanti akan mengurangi ininya ya, sifat transparannya itu ya. Ya. Nah, saya rasa udah ini ya, udah jelas ya Megan ya. Silakan teman yang lain. John Saul Malau ada? Ini nggak ada on cam dia. Atau Alif? Silakan Alif. Oh ada?
Mas Bu.
Oh ya, silakan Alif. Ada? Mau ditanyakan?
Izin nih Bu.
Ya, silakan.
Izin Bu, perkenalkan nama saya Muhammad Alif Ridwan dengan NIM 2094. Izin bertanya Ibu. Tadi penggunaan komposit dengan tingkat presentasi yang tinggi bisa kita lihat di pesawat Airbus 787 Dreamliner yang menggunakan komposit 50%. Kalau contohnya di mobil, kita bisa lihat di merek-merek mewah seperti Bugatti, Ferrari yang menggunakan komposit dengan presentasi yang tinggi. Tentunya keuntungan yang kita dapatkan itu bobot mobil bisa lebih ringan dan bahan bakar yang dibutuhkan lebih sedikit. Namun permasalahannya kan ada di biaya ya Bu. Kalau nggak salah, saya pernah dengar dari Profesor ITB, biaya pembuatan pesawat Airbus 787 Dreamliner itu menggunakan 500 kali lebih mahal dari biasanya Bu. Jadi pertanyaan saya Bu, apakah ada cara untuk menekan biaya produksinya Ibu? Terima kasih Bu.
Okey, dalam kes ini kos ya, kos penghasilan ya Alif.
Iya Bu.
Ya, okey. Disebabkan composite material dia tidak banyak lagi penggunaan dia lah, tidak begitu banyak penggunaan dia dalam industri. Jadi penghasilan dia tu agak sukar. Okey, sekiranya composite material ini telah banyak digunakan dalam industri, processingnya itu sudah menjadi satu processing yang biasa, common, dan saya percaya kos itu dapat dikurangkan lah. Okay. Contohnya kalau katalah metal, kalau sebelum ni pesawat itu dibuat banyak daripada metal. So metal processingnya itu menggunakan casting ataupun menggunakan shaping. Dia datang dalam bentuk kepingan, lepas tu dia shape dan sebagainya. So kaedah tu sudah common di industri. Jadi dan harga untuk processing tu boleh dikurangkan. Tetapi disebabkan polymer composite ini memerlukan special kaedah, penghasilan dia, dan ianya tidak common. Cuma mungkin digunakan dalam pesawat, digunakan dalam otomotif. Beberapa pesawat pun mahal kan, otomotif pun biasanya otomotif yang kereta-kereta yang mahal-mahal saja menggunakan composite material, jadi prosesinya itu belum lagi common. Jadi disebab itu harga pemprosesan itu meningkat. Dan juga kalau kita lihat dalam pesawat tadi, dia menggunakan carbon fiber. Carbon fiber kita tahu adalah mahal. Mahal. Tetapi mungkin pada masa jika kita lihat carbon fiber mahal dan juga processingnya tu mahal. Tetapi bila kita fikirkan dalam segi pesawat itu, mereka mengambil kira penggunaan bahan api. Mereka mahu kurangkan penggunaan bahan api. Dan pesawat tu pun bukannya dihasilkan dalam kuantiti yang banyak. Jadi dengan penggunaan bahan api yang kurang, carbon emission berkurangan, dan properties yang dapat dihasilkannya itu sama dengan properties sekiranya mereka menggunakan metal structure sebagai contoh, dan that's why mereka decide untuk pergi kepada penggunaan polymer composite. Lebihnya kepada pesawat yang ringan, penggunaan bahan api yang kurang, dan juga bagus untuk environment. Okay, that's why bergerak ke arah penggunaan polimer komposit lah dalam industri pesawat.
Jadi karena belum common ya, jadi memang untuk membuka biaya produksinya masih mahal ya, Prof.
Masih mahal ya.
Saya pikir seperti ini, Prof, seperti bioplastik sekarang ya, plastik ya, karena bioplastik itu kan memang biaya produksinya masih sangat mahal sehingga juga plastik konvensional belum bisa dikalahkan, tapi kan karena ya itu tadi belum banyak industri-industri yang yang memproduksi bioplastik. Padahal sebenarnya kalau sudah common, sudah banyak yang memproduksinya, saya rasa itu udah umum aja ya, tidak lagi mahal gitu. Mungkin contohnya bisa seperti itu. Gimana, Alif?
Baik Ibu, terima kasih banyak Ibu.
Terima kasih Alif. Silakan yang lain. Siapa ini lagi? Siapa? Silakan raise hand atau di chat. Sudah mau pukul 11 ini. Ya, mungkin ada satu pertanyaan lagi nanti. Sebelumnya Ibu mau kasih info. Besok itu Prof. Mariyati akan memberikan mini project ya sebagai evaluasi untuk kita. Nanti akan Ibu share assignment-nya, tugas mini project-nya. Silakan dibaca. Bila tidak ada yang memahami, mungkin besok pukul 9 Prof. Mariyati akan memberikan penjelasan sedikit ya tentang apa yang diberikan beliau. Sebentar saja. Jadi nanti akan Ibu share mini project-nya, dan mini project ini dikerjakan berdasarkan kelompok. Kita udah punya kelompok kan dari awal kan dengan yang sebelumnya. Nanti itu saja kita lanjutkan ya. Itu infonya untuk besok. Jadi silakan bergabung semuanya ya, biar memahami apa yang harus dilakukan untuk mini project dari Prof. Mariyati ini. Ada lagi? Cukup? Baiklah Prof, terima kasih banyak Prof untuk kuliahnya pagi hari ini, pagi menjelang siang. Terima kasih banyak, waktu Prof pun sudah disediakan untuk kami. Banyak sekali ilmu yang kami dapat. Kita bertemu lagi esok, Prof. Mudah-mudahan kita sehat-sehat dan mudah-mudahan apa yang Prof sampaikan kemarin dan hari ini bisa diterima anak-anak dan bermanfaat untuk mereka. Saya tutup ya. Terima kasih.
Ya. Terima kasih. InsyaAllah kita jumpa esok. Ya. Assalamualaikum.
Ya, hadir besok ya. Terima kasih Prof. Mariyati. Saya tutup.